Let's get started with the final presentation, which is about scaling DevOps with the Scaled Agile framework and high availability. As I mentioned in my first presentation, many companies, especially bigger companies, say that they are working in an agile way, but the fact often is that the teams might be working in an agile method, but the organization and the business side especially doesn't really. So this means that the kind of requirements that come from that side and the timetables that come that where you need to release software, they are not very mature. They are unrealistic, and SAFe is one of the ways to kind of bring in this organization of or organizing of the requirement handling in the business side. So commonly in enterprises, there are a few problems that are very prevalent. So one of them is the lack of visibility. So the future is pretty unpredictable. You don't really know what's happening at the moment. So you have a lot of trouble figuring out what's happening in a week or 2 weeks or a month or something like that. There's a certain lack of systematic approach. So like I said, the requirements that come from the business side, they might be quite ad hoc. They might not be very thought through. So the formulating of those requirements is not very systematic. The planning itself is kind of improper. So priorities might be shifting. There might be multiple managers who are pushing the thing that is important to them. And then it's kind of up to the team to just jump between those different kinds of priorities. And this often leads to a situation where you have a lot of things that are half done, but nothing that you could actually release. And of course, there's the long returns. So when you are doing this, you are unable to kind of release fast, which means that you have a high cost of holding. So basically what the cost of holding means in this context is that you have something ready and you are sitting on top of it and not releasing it. So it's kind of like not producing the value it could be producing if it would be in production, which is quite the same thing as I mentioned in my last presentation about things starting to produce value only when they are released. So there are a couple of general ways of using Jira. So one of them is to have simply teams in different projects. That's definitely the most common. And then there's the single cramped project style, which is horrible because it causes a lot of performance issues having all of that in the same place. Meaning that when you are accessing a project, you have to load all of the stuff that's in there, and you cannot really very well manage the configuration. If you have different kinds of needs for different people within the same project, you can't really very well make them use the different kinds of schemas or things like that. When you have teams in different projects, it generally speaking means that you don't have visibility into the greater things. You might have somewhat visibility to what one team is doing, but that team doesn't really know what the team next to them is doing or the team next to them is doing. Neither do they know what's happening above them. So who's making the shots? What has been the decision that has been made? Where are we going to? What is the great grand picture? What is the ultimate goal we're going forward? Yeah.
Also, one person, a developer, could be involved in different projects and have to use 4 different projects and try to allocate work between the 4.
Yeah, and the problem there is often also that people don't really know how much they're supposed to, or someone is supposed to spend on one thing. And it's really hard to say, okay, I've now used 25% of my time this week on this project, so I will now ignore you and move on to something else. But generally speaking, what could be the solution? Because Jira doesn't really support this multi-level SAFe out of the box. You really can't have people in separate projects because then you don't have visibility, but you can't really cram them into one project either because then you have problems with configuration and performance. So what you could do is you could create these separate projects. You could connect them and build kind of a hierarchy, a pyramid hierarchy with these issue links. You could share components, you could share versions, and this would then enable you to work towards a common goal and enable visibility by actually giving a larger group of users visibility into different projects. And this kind of also creates a structured flow of tasks, because this means that you have a large or many large business targets which get gradually ground down into more fine-grained requirements, which eventually end up as being singular user stories. So SAFe tackles these problems in its own way. It kind of promises visibility, predictability, and adaptability in this way. What it does is it divides these organizations into portfolios. Within one portfolio there might be large solutions, or there might be straight away agile release trains. And basically an agile release train is something that is supposed to organize the development of things within multiple teams. So it's kind of like the synchronization point for them. If you have a large solution, that would mean that the large solutions job would be to organize multiple trains. So if you're doing something very big with lots of dependencies, you might need that. But generally speaking, you have this agile release train, which moves in program increments. So they're generally 5 sprints long. You might have something like 5 to 10 teams in one agile release train. And the idea is that each of these teams works in sprints, and then they work together in a larger increment, which is the PI. And the idea here is that when you have a program increment, you first have an epic, which is split into features. And each of these features is supposed to be defined in such a way that the teams can complete the whole feature within one program increment. The features are then split into user stories, and each of those user stories is supposed to be of that size that you can finish it in one sprint. So what this basically creates is this bigger schedule within which the teams can work and finish these stories that are interdependent. So you can organize your work between teams 1, 2, and 3 in such a way that when there are dependencies, the things that have to be done first are actually done first, so that at the end of the program increment, you can release the feature at the latest. You can, of course, release it earlier if you can, but that's kind of like the synchronization point. That's when things have to be done. So this is the horrible things that always cracks me up. How many of you have seen this? Yeah, so this is the scaled agile framework full SAFe model from the SAFe site. And this kind of makes sense if you already know what you are looking at. But if you really don't know, then this is well, it's a mess. You don't really know what's going on. So what I've actually done is kind of narrow it down into this, because this is a lot more usable. This is a lot more understandable. So this is basically what I just said. So how SAFe does is it splits the organization into portfolios, release trains, and teams. And epics are handled on the portfolio level, features are handled here on the release train level, and then stories are handled here in the user story level. So we have an epic here. It's split into features, and the features end up here. The feature is then scheduled to be completed, say, on the first program increment. The feature is split into stories, into here. The teams themselves plan on how do they complete the stories, in what order, so that they can actually have all of them finished by the first PI, and then the feature can be released. So it's kind of this taking the idea that is this iterative development and kind of raising it up one level. So it's kind of trying to bring the agility that is already exists within the teams into the kind of organization level or the enterprise level. Because this kind of at least tries to, it doesn't always succeed, but it at least tries to formalize the forming of requirements from business in such a manner that what you ultimately get is something that you can produce. And the PIs themselves also serve as the kind of prioritization point. So once you have a PI designed or planned and its content is decided, no one can come to you and say, oh, do this thing. I'm the manager of this department. Do this thing. This is the most important thing. Is it on the PI? No. Go away. Put it into the next PI. So it kind of gives the mandate for teams to defend themselves as well. How I've actually implemented this in Jira is like this. So I have a project template for each of these different levels. They all come with their own configurations, so issue types and workflows and screens, fields, whatever. And they're kind of linked always to the level below them. So when we have an epic that is linked into this capability, which is something that exists within a large solution, it might as well be linked straight into a feature here. So I have it linked into a feature or multiple features, and then when the stories are created, the features themselves are linked into the stories. And what this does is that you can actually create a structure like this on the fly by just defining a rule set. So bring me all of the epics and everything beneath the epics that is linked to them, and do it like recursively. And there you have it. An instant kind of hierarchy of whatever is going on. And this then allows you to calculate things upwards, so kind of tally them. You can see if you have estimates, then you can, for example, see there that, okay, this epic is going to take 20 weeks because this story is going to take 15 weeks, and this story is going to take 2 weeks and 4 days, and so forth. Of course, these numbers are all made up. No story should last 15 weeks, but you get the picture here. You get the idea why I'm doing this. So this definitely creates some visibility, because this is something that should be visible to every single developer in the organization, or at least within this portfolio.
Can you give access to external stakeholders only down to the feature level, but not to stories?
Yeah, you can, because they are different projects. So you can basically set up a group that only has access to features and epics, or features and stories, or just features. Anything, basically. So why would you use the system? Well, because it does allow this clear structured process for defining these targets and requirements, which is often a problem in bigger organizations. Working in sprints and program increments also allows you to react to changes. So, which we were talking about on the Devops side when we talked about Agile and how it kind of improves upon things that Waterfall is lacking. And one of those was definitely the ability to react. So there might be changes in laws, there might be changes in the marketplace which require you to react fast. And this iterative way of working actually allows that. Plans are themselves based on actual mutual understanding, or at least that's how it should be. I mean, I've heard of PI plannings where teams have not agreed on what's being planned, and the kind of response that's given to them is that, well, then you will sit down and you will be here until you have designed something that you can approve, which means that the people are going to work overtime, which means that the people then just show thumbs up because they don't want to work anymore. But in a perfect world, that's at least how it should work.
You can introduce a concept called PI pre-planning.
Of course. And the post-planning, where you go through whatever. But how it's supposed to work is that the teams plan this together with the business side, so that there's kind of mutual understanding of what we are striving for, what is the real goal here. And that also means that since the teams have been a part of the design themselves, it's actually based on what they can deliver, what they promise they can deliver. So it's an agreement on what we could do. And as we mentioned in the DevOps side, this leads to smaller batch sizes, and smaller batch sizes then lead to faster ability to release, so faster returns, reduced cost of holding because you don't have to sit on the ready-made code you have. And like we said as well on the DevOps side, this means that since the batches are smaller, there's a reduced risk of having a severe failure in production. And of course, you really need to avoid creating silos with this, because it's really easy for people to just work within their own team projects and ignore everything else. But you definitely need to take into account on how things are done, for example, at the PI planning. And the fact is that the separate teams still target the same features, so that's kind of that gives them a sense of common target, common goal. And there has to be cross-communication between different teams if they have things they do separately, but a common goal they aim for. And also with blocking features, or rather blocking stories. And the success here is measured with the end result. So it's not about how many stories a team can deliver. What's the velocity of team number one versus the velocity of team number two. But kind of the sum of the whole. Have we succeeded in making it to the goal we have set? Have we released this feature and does it work? So that's a pretty important thing. And the other is that since you have a visibility into what you're doing, it also creates a sense of understanding what's happening and sort of a sense of purpose. Everybody's been in the situation where you're doing some work which you don't think is important and you have no idea why you're doing it. But perhaps if you know what it's for, it might give you some meaning. It's of course not guaranteed, but it's there. SAFe and DevOps themselves. SAFe is in its core, it's not only compliant with DevOps, but it actually is pretty much DevOps because DevOps in itself is also about deconstructing silos. And it's about having this cross-functionality and agility there. And that's exactly what SAFe is trying to do, but in a bigger scale. So what you could do is just model this in Jira by creating these template projects. And when you're creating new projects, you base them all on these templates. This means that they have kind of a unified way of working, unified checking points, unified comparison points. So when you have multiple teams that are using at least somewhat similar workflows, you know that when some issue is in the status done, it means that it is done, instead of having one team use the done, meaning that, okay, we have now completed the implementation, and this done means that it's ready for testing. Okay, because that gives you a completely false idea of what's going on when you are looking at that bigger picture. Well, then you do the linking, which I described earlier, and you can then use those links to get visibility like this. You can use different kinds of boards, agile boards, so Scrum and Kanban boards. Generally speaking, Kanban for portfolios and release frames, because they don't revolve around sprints, but Scrum does. And you could use Scrum for the release train level since you are running program increments, but they would simply be something like 10-week sprints. Yep.
Now that Trello has been bought by Atlassian, and if you happen to have a business unit that loves Trello and hates Jira, have you made any integrations with this?
With this system, I haven't.
Yeah. Do you think it would be possible to get visibility to Trello?
I could see a scenario where you would get information out of Trello and kind of modify it to be Jira issues, so that you would kind of replicate the Trello data into Jira.
And how about the other way around? There are some connectors that I've never tried.
Yeah. Given there are sufficient kind of mappings on what information should be what, I don't see it's impossible. But at least the other way around, it really requires you to have kind of an empty project in Jira, which the stuff gets replicated into. And then in the end, definitely just start automating everything. That's the DevOps way. So calculating prioritization stuff for features. So it's called the WSJF, which is the weighted sorted job first. So it uses user, business value, time criticality, risk reduction, opportunity enablement, and job size to kind of calculate a magic number that is supposed to give you the best way of prioritizing work. So you can automate that. You don't have to calculate it by hand. That's one way. You could have automatic calculations of estimations. So if you, for example, have a feature that is timetabled to be in PI1, you have another feature that is timetabled to be in PI2. They both have the time windows, and this epic consists of those two features. So it basically covers PI1 and PI2. Now you can automate kind of using the links and reading certain fields and then returning the value of when is this supposed to be done. Because you can compare the kind of PI values, okay? If PI2 is ending at this point, and that's the last part of this epic, then we can return that upwards and see that, okay, this epic should be done by the end of PI2. And of course, then all of these reporting things. So as Tuomas showed earlier, our track and drive solution, you could very well use that to visualize what's happening within safe portfolios and safe release trains and safe projects. Then let's move on to the high availability part. So this is mostly about Atlassian data centers. So what exactly is an Atlassian data center? Well, basically we are talking about a multi-node system. So where you usually have your Jira, you have something like a Jira server and a database. But when you start moving towards data center installation, you do something like upgrading here if needed, connecting a load balancer, then setting up your file system to be shared, and then add another server node and connect that to the shared file system. And finally, you set up the load balancer to even the load between these two nodes. And you could, of course, have more nodes than two. The data center version is kind of a different version than the server version. It uses its own licenses, which are a bit more expensive. But if you have a big organization, it might be worth it. And this works very much the same way for Confluence and Bitbucket as well. So in Confluence, you have multiple nodes in the same way as you would have in Jira. The only difference is that in Confluence, the version 6 brought on this collaborative editing feature, which means that you can edit a document with your coworker as you would in, say, Google Drive. This is handled by a component called Synchrony, which also requires its own nodes. So that's kind of the magic piece here in Confluence. So you have to have your load balancer that balances stuff between both the Confluence nodes and the Synchrony nodes to enable that. As for Bitbucket, this is pretty straightforward. So multiple nodes, have your load balancer in front, and then have different services for, of course, the shared file system, and then Elasticsearch if you wish to search through whatever is in the database. Now, why do we need them? Yeah.
One question about Jira. There was a discussion that it's a good solution to move all Jira instances to one big Jira instance. But the problem with big Jira instances is that the plugins are ridiculously expensive. If you need some small features which would be used by 10 people, you have to buy it for the whole big Jira instance. And that makes a problem that basically what you'll end up doing is that you don't buy any plugins because they are so expensive for just few people to buy, and then you have to integrate some other softwares on top of the APIs to make that same functionality. And I don't know if that's a better solution than having two different Jira instances.
Well, that definitely depends on what kind of an organization you're running. So if whether or not the cost of some plugins is a lot or just a drop in the ocean.
It's usually a lot if you go to the upper level of those.
Yeah, it can be something like easily multiple $1,000s per year, something like $8,000 per year or $10,000 per year.
That's quite a lot for like simple SQL or whatever extension to some language in the Jira.
Yeah,
JQL.
I think you need to go through a cost analysis before you make a decision. So whether it makes sense to have like, let's say that you have seven of them today. So maybe going directly to just one team doesn't make sense, but maybe having two or three of them is more sensible. So, but you're right. I mean, it's not as simple as just migrating everything to a single instance.
Definitely not, but it's also not that black and white because there are multiple kinds of costs that need to be considered there. I mean, if you're running multiple Jira instances, that means you are running multiple servers. Who is taking care of the information security there? Who is taking care of the OS level patches, kernel level patches, Jira upgrading those plugins, making necessary adjustments and tweaks. So it's always like there is more hidden costs there than it would appear at the very beginning.
Total cost of ownership you need to look at, right?
Yeah, and this is actually a pretty good slide about that. So this is a very naive calculation. But this is just to give you an example of how these hidden costs can actually pile up. So if you have an organization which has 1,000 people, and let's say you have 10% of those people are consultants, and that they bill about 100 euros per hour. In reality, the amount of consultants is usually higher than 10%, and the billing might be higher or a bit lower than 100 euros. But let's say that your instance crashes, your Jira crashes, your source control system crashes, and all of these consultants lose a bit less than 1 day of working time. So that actually costs them 600 euros per consultant who are doing nothing if they don't have the tools. Now you have 100 consultants. So that's a 60,000 euro cost. Whereas data center would have cost you $24,000 euros. And now if you start thinking about bigger organizations with more consultants and higher prices, the 24,000 for the data center license doesn't really sound that much anymore. So it's all about perspective and how to kind of uncover the hidden costs as well. So what other features does this data center approach have? Well, first of all, you have multiple nodes, which means that you can do 0 downtime upgrades. You can take one node, you can upgrade that to a new version, bring it up, go to another node, do the same to that, and then trigger the general version upgrade, which means that you can upgrade in the middle of the day with no breaks to the user. Now, if you have thousands of users, this is a huge deal. And this is also a huge deal for whoever is in operations. Because I can tell you that upgrading software during the week, midnight, on the weekends, it's not very nice. Especially when you have a lot of software that you need to take care of, because you end up doing that multiple times a week. You, of course, was there a question? No. There's also load balancing. So that's pretty much self-explanatory, because this really helps you to avoid slowness due to load balances. Because you have multiple nodes, you have a load balancer, you start having requests in, and the load balancer takes care of sending those requests to different nodes. So the load is balanced by the load balancer, which you imagine. You have disaster recovery and failover options. So if you have a really mission-critical system, you can have an offsite, and by offsite I mean now that you have a data center where you have your normal DC, and then you have an offsite data center where you have another kind of copy which is ready to go. So you set up kind of replication to the other data center, and if there's, say, an earthquake or a tsunami or whatever, you automatically can trigger the traffic to go to the other data center. So you don't have to lose the functionality of the software, even though the data center itself is physically destroyed, which is kind of awesome. Do note, however, that this failover setup is not necessary unless all of your nodes die at the same time. So if you have a multi-node data center and one of those nodes crashes, it doesn't matter. You just bring up another. So unless all of them crash at the same time, you're just fine. And of course, performance scaling. So if you have huge load spikes, you can then actually bring up additional nodes to handle the load at times. This is definitely useful if you have, for example, some events that require a lot more processing power than your day-to-day use. So, how do you upgrade to this data center installations? So, first you have to design the transition on how this should be done. So you should spare about 5 hours, or rather, you should reserve about 5 hours of downtime to do this. Second phase is that when you have the transition itself figured out, you do the transition in test. So you see if everything works as you designed it would, and then adjust if it doesn't. Check your shared volumes, check your database and permission schemes so that they actually work. So basically, make sure that whatever you're doing actually works in the test environment. Then in the third phase, you plan the service break. You document all the steps you intend to take so that you know exactly what you're doing based on the test server installation. You can, beforehand, migrate your data using rsync to the other node. So basically, rsync always transfers the delta of whatever there is in the files. So you can kind of beforehand already start rsyncing attachments and pages and whatever. And then when you have the final service break, you can just transfer the rest with rsync. So that kind of minimizes your downtime. Then when you actually have the downtime, you first off take the database backup, you kill the node, you upgrade it, check that it works, and after testing that it works, you bring up the node 1 into the cluster. And then more nodes. And after that, it's all set to go. Then you start enjoying your hot upgrades, you start enjoying your booting midday, you start managing your cluster live. So with the load balancers, it simply brings up additional nodes, or you can just bring up additional nodes to handle it. It should be okay. There's a story about REST API crashing the whole system on startup. So there was this Confluence instance of which the REST API was used extensively by automation. And there was this nice bug in Confluence which caused the whole server to crash if there was a REST API call made during the startup. Now, this meant that there was some bot that was running REST API queries all the time, and whenever we were trying to bring the Confluence back up, it instantly crashed again because there was this call to the faulty REST API service. But if we were to have DC at that point, that would have not been an issue because we could have just brought up multiple nodes and be fine with it. Okay, let's say you have faulty plugins. Let's say you have some other kind of problems within your server. You have memory leaks here and there. Well, it's really no problem because when you have one node that is leaking memory, you just boot that node, bring it up again. Problem solved. You have more memory now and you didn't even have to take a service break. Okay, there are long-running queries that can eat performance. So, for example, if you're trying to extract data out of Jira to take it to, for example, let's say Tableau or something like that, what really happens is that these queries can last a long time and they can really hog up a lot of resources. So this would kind of be a spike in the use there. But with DC, this is really not a problem because you can just balance the load on another node or other nodes while this long-running query is running there. And while DC is not completely immune to server crashes, it does mean that one node crashing doesn't really crash your system. It still keeps it operational. And then you just bring up another node and you're fine. Any questions?
Can you just very briefly compare the DC solution with Atlassian Cloud?
Briefly, no. Yeah, the thing is that the server and the cloud way of doing things, they're kind of like different products. They have, you can do a lot of different things on the server that you cannot do in the cloud. Cloud is a lot more limited, and the data center itself is just an extension of the server version. So there are a lot more customization options that you can do on the server. For example, I don't think the Atlassian cloud supports bringing in, for example, your corporate AD at all. But that is something you can do on the server system. Any other questions?
I have a question about the root, but
Yeah.
that's fine.
Yeah, definitely.
So I was wondering about the kind of devout tools which you have chosen there and shown in the slide earlier.
Yeah.
So why Jenkins and not the Atlassian's own CI solution?
The Bamboo is there as well.
I think we had both of them.
Yeah, they're both there.
Yeah, all right. Sure.
Yeah, always it kind of depends on what the usage is. What are you using it for? And does the tool fit the need?
I was already wondering that it's so rare in Finland, but
Yeah, it kind of is, and a lot of people who are using Bamboo are actively also migrating into Jenkins. That happens.
I've seen it going the other way around as well. So.
Yeah, that's true.
People are moving from Jenkins to
is it
Bamboo.
still very expensive?
Depends.
Yeah, the definite advantage with Jenkins is that it's so widely used that there are a lot of ready-made solutions for it.
And a lot of expertise available.
Yeah, it also leads you to the plugin hell, which means that you might have 1 million plugins installed on your Jenkins instance, and you might really struggle with maintaining it and having all of those jobs work. But to begin with, if that kind of enables you to do things that you wouldn't otherwise be able to do, it's kind of a trade-off you might want to take.